Section 4.4, Perimeter, Area, and Volume. This section will help you determine the perimeter of a figure, identify the area of a figure, and determine the volume of a figure. Let's take a look at some definitions here. Perimeter is a one-dimensional measure. So we measure perimeter with line segments. So perimeter have units of length, such as feet. So one dimension, so our units are just one dimension when we list them. Feet, inches, meters, centimeters, something like that. Area now is a two-dimensional measure. So we measure area with squares. So area has units of square length, such as square feet or feet squared. Volume is a three-dimensional measure, and we measure volume with cubes. So volume has units of cubic length, such as cubic feet or shorthand, feet to the third power. That's how we write cubic feet shorthand. And up here with square feet, that's how we write the shorthand. So either of those are fine for describing volume or area. Go ahead now and pause your video player and answer these two practice questions. When you're done, hit play to see how you did. So practice question 1. To find the perimeter, add the lengths of the line segments that go around the figure. Well, this is pretty straightforward. So we're going to start at some point here and basically go around this figure. Going around the outside edge of these figures. As we go around, we're just going to add these sides up. So I'd have 7 plus 2.5 plus 10 plus 9. I want to add that all together. Let's see, 17, 19.5, 28.5. And now, since we're talking about a length here, that's 28.5 feet around this figure. So we want to make sure we include our units there. Practice question 2. To find the area, add the number of squares that cover the figure or use the formula. Well, let's do both here. So first is we're going to find the area of this rectangle by counting up the squares it takes to cover it. So I have 1, 2, 3, 4, 5, 6, 7, 8. So that is 8 square feet, or I could just write 8 and then feet squared. They both mean square feet there. But notice this is how we find area. We figure out how many squares it takes to cover the figure. That's what we're doing when we're finding the area. Now, most of the time it's not convenient for us to do all this counting. So what we do is we just do this. We use this formula. Area is length times width. Well, the length of this thing is 1, 2, 3, 4 feet. So this thing is 4 feet. And the width is 1, 2, 2 feet. So the shorthand way to do this is area is going to be 4 times 2, which is 8. And now I want to make sure that I write square feet on there because I'm saying it takes 8 of these squares to cover this figure. Go ahead and pause your video player now and answer practice question 3. When you're done, hit play to see how you did. So to find volume, add the number of cubes that fill the figure or use the formula. Okay? So we're taking a look here. We're going to count the cubes it takes to find the volume. So basically we're just going to go around here and count these things up. So I'm going to have 1, 2, 3 in the first row, and then I would have 3 in the second row again, so I'm up to 6. Then I would have 9, because there's another 3 if I was counting back like that. There'd be another 3 there. So basically one layer of this cube takes 9 of these cubes to do that. So here's 9. The next row is going to be another 9, so now we're at 18. And then finally counting this top row, another row of 9 would give us 27. So this would be 27, and we would want to say cubic, and let's see, centimeters. These are centimeters, so 27 cubic centimeters is how I would want to answer that. Or the shorthand way over here of finding this, we could say, okay, volume is length, which is 3, times width, which is again 3, times height, which is again 3. Counting up these centimeters, 1, 2, 3 centimeters this way, 1, 2, 3 centimeters this way, and then 3 centimeters deep. So multiplying all of those together, you'll see that we'll get 27, but again, we want to make sure that we write either the word out cubic centimeter or centimeter to the third power. Because to find volume, what we're doing is we're figuring out how many cubes it takes to fill up this volume, or in this case, the larger root. Okay, here are some common area and volume formulas. So take a look at these and start working on these. Let's make a little correction here, though. This should be a rectangle. It is a square, but a rectangle is more general here. So area is length times width for a rectangle. So these top formulas here are all for area, and then the second row of formulas, these are now three-dimensional shapes. So notice in 3 dimensions we're finding volume in all of these cases. Go ahead and pause your video player now and answer practice questions 4 and 5. When you're done, hit play to see how you did. Alright, question 4. We're asked to find the area of this shape. Well, this shape is not pictured in our area formulas, but we can make this shape with our area formulas that we have. What we can do here is we can divide this off this way, and that is actually going to make 2 rectangles. Let's change that color there. So I'm basically thinking I'm going to divide these rectangles right there and make 2 rectangles. So in order to find the area of these 2 rectangles, remember area for a rectangle is length times width. So I need to find the length and width of each of these rectangles. Let's see, let's look at this top rectangle up here. The length is 11 centimeters. The length is 11 centimeters and the width is 4 centimeters. So that area is going to be 11 times 4, or 44 in this case, square centimeters. Let's take a look at this other rectangle here. Looking for length and width. Looks like my length is going to be 6 and my width is going to be 5, and so the area there is going to be 30 square centimeters. So I want to add those 2 together, and that will give me 74 square centimeters for the area of that figure. Now you may be wondering which one of these dimensions, when I was going through this, you may be wondering which one of these dimensions is length and width. And honestly, there's an argument for either case, so it doesn't matter which ones you put. If you used length was 4 and width was 11, it won't make a difference here. Alright, practice question 5. So we're looking at this figure, and that figure does not match any of our area formulas, but we can kind of split it up here and figure out 2 shapes, and it goes like this basically. If I draw a line across here, I have a rectangle. So here's my rectangle, and notice this is half of a circle. The top is half of a circle. So let's start with the easy one, which is to find the area of the rectangle. And the area of the rectangle again is length times width. So notice my length and width, 12 and 18. So my area there is going to be 12 times 18. So the area of just the rectangle is going to be 216 square feet. Now let's talk about this circle. So for the area, our formula for area of a circle is pi r squared. Now notice I don't want a full circle here. If I use pi r squared, I'll be finding the area of a full circle. So I want to find area of just half the circle. So one of 2 things I can do. I can either multiply this side by a half or divide it by 2. I think most of the time for calculations, dividing it by 2 will be an easier calculation. So there's my formula for the area of half a circle. All I need to add now here to find this area is just the radius. If I figure out what the radius is, I'll have enough information to find this area. So let's see. Remember, the radius starts at the center of the circle and goes out to the edge. So that distance, the radius, is half the distance across the circle. And notice the distance across the circle we have right down here. It's 12. Because remember, in a rectangle, opposite sides have equal length. So this is going to be 12. We'll cut that in half. That's going to be 6. So my radius then is 6. So let's take a look at my formula then. I'll have pi times 6 squared divided by 2. So pi times 36 divided by 2. So I'll punch that into my calculator. Let's see. 3.14. And you could use your pi key if you want to on the calculator. I'm using 3.14 times 36 equals, then divided by 2. That's going to give me 56.52 for the area of half of this circle. And that is square feet. Now I want to add these together, so I'm going to go, the total area here is going to be 56.52 plus 216, and that's going to give me 272.52 square feet. Now, if you used something different for pi as opposed to 3.14, like if you used your pi key on your calculator, your answer will be a little bit different than mine. But if it's close here, that's good. You know, that's the problem with pi, is we can't always get the same answer. But if you use something else for pi and you're very close to this answer, then your answer is correct as well. All right, now go ahead, pause your video player and answer questions 6 and 7. When you're done, hit play to see how you did. Question 6. All right, we're going to divide this thing up right there. So we get a rectangle in the triangle. The area of this rectangle is going to be 7 times 9, which is 63 square inches. Now, we want to find the area of this triangle, and here's our formula for area. Area equals 1/2 base times height. So I need to find the base, and I need to find the height of the triangle. The base is going to be the distance across the bottom here, and notice that's going to be the same as this side, or 7 inches. The height is going to be a little bit trickier. The height of the triangle is going to be right here to the tip. Notice we have this dimension all the way across is 14 inches. So from here all the way up to the top is 14 inches. Notice the side of the rectangle, we also have that. That's 9 inches. That means this distance right here would have to add to give us 14. We'd have to take 9 plus this distance, this height, to give us 14. So let's see, that height is then going to be 14 minus 9, which is going to give us 5. So the height of my triangle there is 5. So let's see, I'm going to take 1/2 times 35 to give me 17.5, and that's again square inches. So here's the area of the rectangle, here's the area of the triangle. I want to add those two together to give me a total area. So 80.5 square inches for the total area. All right, question 7. Notice in question 7, it's very similar to question 6, except now instead of adding a triangle on there, we are going to be subtracting a triangle away. So let's start by finding the area of this entire rectangle, and so that's going to be 12 by 7. So the area of the whole rectangle is going to be, let's see, 12 times 7, 70 plus 14, 84 square meters. Now we want to subtract the area of this triangle away. Well, we're going to need base and height. Let's start. The base is easy. It's going to be the same as this side over here, so that's 7. Let's take a look at that height now. We're looking at height. So let's see. Oh, it's given right here. Notice that distance is 5. So we know the area of this rectangle, so this triangle, area of that triangle is going to be 1/2 base times height. So 1/2 times 7. 1/2 times 7 times 5. That's the same calculation we did over here. So we know that that's going to be 17.5, in this case, square meters. Okay, so now I'm just going to take the area here. I'm going to take 84 and subtract 17, subtracting the area of the triangle away. And we get 67. And we get 67 square meters for the area of that shape. Okay, pause your video player now and answer practice questions 8, 9, and 10. When you're done, hit play to see how you did. All right, question 8. We're trying to find the volume of this cone. And so the volume of the cone is 1/3 pi r cubed. So really notice there's only one variable in here. It's just the radius. We need to find the radius of this cone. Okay, so the volume of a cone is 1/3 pi r squared h. So notice we need two pieces of information here. We need the radius and we need the height, and those are given. Has a height of 10 meters and a radius of 5 meters. So we're just going to plug that in. 1/3 pi. My radius is 5, so I'm going to have 5 squared, and my height is 10. So let's see. 5 squared is 25. 25 times 10 is 250. So let's see. I think this is the easier way to think about this. We said that was 250 times 250. Multiplying by 1/3 is the same as dividing by 3. And I think setting it up as a division by 3 is an easier way to think about this, because what I'm going to do then is I'm going to multiply all of this stuff together on top, and then the last thing to do is to divide by 3. So I'm going to take 3.14 times 250, get an answer, 785, divide that by 3, and I'm going to get 261.6 repeating, so I'll round that off to the tenths place, and let's say 261.7. Now I want to write my units of measure. Notice I'm given in meters. We're dealing with volume, so I want to have cubic meters for my answer there. Okay, the diameter of a sphere is 10 meters. We're asked to find the volume. Okay, so the volume of a sphere now is 4/3 pi r cubed. So notice the only piece of information we need in this formula is just the radius of the sphere. And so it's given that the diameter of the sphere is 10 meters, so the distance all the way across the sphere is 10 meters. That means the distance for the radius of the sphere will be half of that. Will just be 5 meters. So let's see. And again, I'm going to do that same thing I did last time, splitting that fraction up. 5 cubed over 3. So the last thing I'll do is divide by 3. So let's see. 5 cubed will give me 125. Over 3. So I'm just going to punch that in now. 4 times 3.14 equals times 125 equals divided by 3 gives us 523.3 repeating. And notice it's given in meters. This is volume, so then I want to have cubic meters. All right, let's take a look at question 10 now. So find the volume of the truck's tank. Notice this truck has a cylinder for a tank, and the distance across the cylinder is 8 feet, and the height of this, or length of this cylinder, is 25 feet. So let's look at the formula for finding the volume of a cylinder. Pi r squared times the height. So I need the radius and I need the height. The radius, if the distance across the entire tank is 8 feet, then the radius will be half of that. So it's going to be times 4 squared, and the height is going to be 25. So let's see, 4 squared is 16. So I'll take 16 times 3.14 equals times 25 equals 1,256. And then let's see, it's given in feet, so then I want to have cubic feet for my answer, because we're talking about volume here. Go ahead and pause your video player now and answer practice question 11. When you're done, hit play to see how you did. Alright, question 11. We got two things going on here to make this scuba tank. We've got a cylinder on the bottom, and then we've got half of a sphere on top. So let's start with this volume of the cylinder. So the volume of the cylinder is pi r squared h. So what I need is I need the radius and I need the height from the drawing there. So let's see. Pi, the distance all the way across is 11 inches, so the radius will be half of that. That would be 5.5 squared. The height is given right here is 24 inches. Alright, so let's see. So 5.5 squared times pi times 24. So that gives us 2,279. Let's round, it's 0.64. So since it ended there, we'll be accurate. We'll stop right there. Now we need to find the volume. So that's the cylinder. So we found the volume now of the cylinder part. Now I want to find this half of a sphere. So remember, the volume of a sphere is 4/3 pi, 4/3 pi r cubed. And I want to find half of that. So basically what I'm going to do is I'm going to take and multiply this times 1/2, or divide my answer by 2 in the very last step. So let's see. 4/3 pi, sorry, and that was r cubed on the top. So let's see, the radius of this sphere. Notice if the distance right here's my distance across, which is 11 inches, so the radius of this is going to be 5.5 again. Okay, so I've got my information in here. The way I'm going to calculate this, first thing I'm going to do is I'm going to multiply all the stuff in the numerator. And notice I'll have a 4 in the numerator, pi in the numerator, 5.5 cubed, and then a 1. Multiplying by 1. I could write the 1 in there or not write the 1. Now notice in the denominators I have 3 times 2. I think setting it up this way is going to make the calculation a little bit easier. So let's see, the first thing I'm going to do on top is cube that 5.5. So I'll go 5.5 x to the y to the 3rd power is going to equal 166.375. And I'm going to take that times pi, 3.14, equals, and then times 4. So that gives me basically 208.967. And notice in the denominator I have basically just 3 times 2. So that's going to give me 6. So I'm going to take that 2089.67 and divide that by 6. And so that's going to give me then the volume for the top of this tank as 348.28. So now to find the total volume, I'm going to add these two together, the volume of the half sphere on top of the tank and the volume of the cylinder at the bottom of the tank. And then that's going to give us 2,627.92. And now this was in inches, and since we're dealing with volume, I want to write that as cubic inches for the volume of this scuba tank. All right. Go ahead now and pause your video player, and now we'll do the last practice question for this section. When you're done, hit play to see how you did. So practice question 10. Silos store grain for livestock. Grain is filled to the top of the cylinder, but not in the dome. So I want to stop right there and interpret what that's telling me. Grain is filled to the top of the cylinder, but not in the dome. So basically, right up to here is where they fill the cylinder. They don't fill this top dome up here. So they fill it right up to the top edge there, and is fed to the animals during the winter months. If the thickness of the silo wall is 6 inches, what volume of grain can be stored in the large silo? So notice on the inside of this silo, these are blocks, basically cement blocks or some sort of concrete that's making the silo. So there's some thickness to this wall. So we want to not include that thickness when we're calculating the volume of this cylinder. So basically all we have to do here is calculate the volume of the cylinder, but we want to kind of remove this wall when we're thinking about now the distance across the inside of the cylinder. So let's see, the thickness of the wall is 6 inches. So notice we're going to have a piece of wall here on this side of 6 inches and a piece of wall here for 6 inches. So that's basically going to reduce the inside diameter of this silo by a full foot. 6 inches here, 6 inches there. We're going to decrease the diameter by a foot. So we don't want to use 12 here. We actually want to use 11 feet for the diameter of this cylinder. So let's see. Here's the volume of a cylinder is pi r squared h. And now I just want to plug that in. So I'm going to have pi. My radius now is 11. And my height from here, just the cylinder, is going to be 30 feet. So times 30. So let's see. I'll do 11 squared. 11 times 11 times 3.14 times 30. And that will give me the volume of the inside of this silo. So 11,398.2, and that's going to be cubic feet since we're dealing with volume.